Hi everyone and welcome to this course. And I must admit I'm really looking forward to, really excited to teaching you how to use Apple's own Swift Playgrounds app to learn how to write Swift code. So you're probably here because you've got an interest in apps. Maybe you want to build an app, maybe you want to upgrade your language skills in coding, or perhaps you've got that great idea for an app that's going to make you your fortune, make you millions, and you want to build that app. But the reality is though, you do have to code. So you may really enjoy thinking about the features and functions, the layout and the interface of the actual app, but at the end of the day you do have to code, and that's an important message from this course. And that's why this course is so good really and great, because it's going to teach you the fundamentals of the language but in a real fun and easy way. So you may have taken other courses where you've learned how to build an app and maybe write some basic Swift code. Perhaps you've even looked at Apple's Swift code book, which is, I think it's free from the iBook store. I think it's about 500 pages. So you may have tried to do it yourself a little bit, but this app really is a real fun and exciting way of learning how to write Swift, because it's teaching you the fundamentals of the language. So just like when you learn a spoken language, it's different to your own, you've got to learn the alphabet and the grammar. Well, this course will take you through the basics of a coding language. Anyway, I hope you enjoy the course. There's a couple of introductory lectures first, and then we'll get on with writing the code. Excellent. Hi, this is a new lecture for this course, and I just very quickly want to say, before you start learning, you may find it beneficial to subscribe to my YouTube channel. I'm now posting a lot of content on there, which will supplement the material you learn in this course, as well as providing a quick and easy reference in the future to any skills that you may want to remember. So if you go to the resources for this lecture, click on the link, subscribe to my channel, and you won't miss any of the future updates. So once you've done that, I'll see you in the next lecture. Thank you. Hello. Have you ever tried to learn a different language, whether it be computer or spoken? You will probably know that support really goes a long way. It can be quite difficult at times. Now, there are many groups and forums on the internet which will help you to learn a computer language, for example, the Swift programming language. But I thought if we have our own Facebook group for this particular course, then it'll be very relevant to what we're learning here, rather than have to sift through lots of information. And also that way, if you have any questions, I can come onto the group and answer any questions and provide any help that you need. Or if you're a student yourself, perhaps you're further along in the course, you can go back and help out another student along the way. If you've ever written any code in your life, and you probably know how frustrating, and it really can be at times. I've written chunks of code before, and there's been a bug somewhere in there, and you're looking at it 2-3 hours, and you just can't see where you've gone wrong. And then you realise it's just a simple typo, or you've missed a bracket off, or something like that, and it can be so frustrating. So if that is the case, then this group will be a really good place to go. You can vent all your anger out there and get some assistance and help too. Now, it's not essential for the course. If you don't use Facebook, that's absolutely fine. But if you do want to join the group, then click on the link and the resources for this lecture and sign up. Anyway, in the next lecture, we'll actually get our hands on the Swift Playgrounds app. So join me there. So let's go on then and start learning by downloading the app and our first playground. So I'm going to assume you know what the App Store is and how to download an app. So let's just quickly go through that process now. So you need to go to your iPad now then. So I have mine open up here. And the first thing to do is download the actual app itself from the App Store. So if you tap on the icon that says App Store, I'm sure you're familiar with this anyway, you can go into the search bar at the top and we'll start typing in Swift. And as we do that, it's that top result there, Swift Playground. So we'll tap on that, and we can see there, there's a few have come up, but it's that one, the very first one there, Swift Playgrounds, with the Swift logo as the app icon. We'll just press on that actually. So you can, if you want to, you can go into here, you can see all the screenshots and reviews and things like that. But ultimately, what you need to do is press on that Get button, and that'll download the Swift Playgrounds app. So once we've done that, it should only take a few seconds to download. We can now open up the app, so we'll press on it. And as you can see there, we have in the top left hand corner Get Playground. And then I already have 5 different playgrounds already downloaded. But for you, you should just see that plus button. So if you press on that plus button for Get Playground, it'll open up all the different playgrounds which you can download and different things you can do there as well. And for this first course, we just need to download the very first one there, Learn to Code 1. So just press that Get button there, and it'll download that Learn to Code 1 Swift Playground. Right, you're all set. So before we start, it's important to know how this course is structured, which will make sense as we go through the course. So if you join the next lecture, we'll explain that. So as you can see, there are different levels and challenges contained within each different playground. So in this Learn to Code playground, it's split into different sections, and each section will teach you a fundamental aspect of the Swift programming language. So each section begins with an introductory video, which is usually 4 or 5 slides you just scroll through, and then there are 5 or 6 challenges in each section to help you master that part of what's being taught. In this course, we won't go through every challenge. There really is not much point in doing that. If you just sit and watch me go through all the different challenges, you're really not going to learn yourself and get into sort of the typing and thinking about things yourself. So what I've done then, I've structured in a way where in each section we will go through 2 or 3 challenges together, and then you'll do the other 4 or 5 on your own. But don't worry, if you do get stuck at any point, and if you get stuck on one of the challenges I'm not teaching, you can just go and post a question to myself, go on the Facebook group, and I'll be happy to help anyone there. I think this mixture of me going through a couple of challenges together and then you doing a few on your own is the absolute best mixture, the best way of learning this Swift language in a really fun and interactive way. Anyway, I hope you've enjoyed these introductory lectures, but of course now we can get on to the main part of the course and start writing some Swift. See you there. So here we are. We have the default screen now in the Playgrounds app. You can see I've downloaded a few little playgrounds there as well. And so we'll go straight into the course now then. So we've enjoyed the introductory lectures, but now if we go to that first one there, Learn to Code 1, and this is going to be right at the start and the basics of learning how to code. So we'll click on that one there. Hopefully it'll open up. And as mentioned in the previous lecture of how the course is structured, for each beginning section there's a little video type or screens to scroll through, which Apple have designed to help us understand what we're about to learn. So this is Learn to Code 1, and this is the first section, which is simple commands. So let's go through these. We'll press the arrow button at the bottom there. You can see it's page 1 of 8. So have you ever followed a recipe to bake something delicious? I'm sure most of you out there probably have. And so you know it takes different things and different quantities. So let's see what the next page says. Or if you've maybe found instructions to assemble something cool, and that is cool, isn't it? That's a drone or a quadcopter there, and instructions for that. You need to follow the instructions in the correct order, or you'll end up with something unexpected. And we just saw the blades fly off then there, didn't we? So go to the next page. So writing code allows you to create your own set of instructions for your iPad to carry out. Your goal is to figure out which instructions, in which order, will result in something great. That's important there. So you'll start by writing commands to move a character named Byte around a puzzle world performing tasks. For example, you'll tell Byte to move forward, and as you can see there, the code there is move forward, and the second word is capitalised, and then open and close bracket, which we'll come to in a moment anyway. Also to collect the gem, which he jumps up and collects, and you'll see that a few times throughout the course as well. And I was just mentioned there about these words being mashed together. So again, code is punctuated and spaced like human languages, but commands have no spaces between words, and that is really, really important. And also, at the end of commands, you'll see brackets or parentheses, and again, you'll see why later. So that's the introduction then to simple commands. If you press the button at the bottom, we'll go to start coding. We'll see you in the next lecture. So hello everyone, here is the first level in this Learn to Code 1 Swift playground called Issuing Commands. So before we actually go ahead and tackle the challenge, I just thought we'd spend just a few minutes just to familiarise ourselves with the actual app itself and how it's all laid out and what all these buttons and things do, which might be handy for us all to know. So if we start off there in the top left hand corner, you'll see the 4 squares. Now if you press that, it just simply goes back to your main menu in your app. So let's go back again. So that's just to go back there to that main screen. Now the one next to it, the bullet points and the lines, that's going to show you all the different sort of levels in this Learn to Code 1 playground. So we've just seen the introduction in the previous lecture. We're now on issuing commands, that's highlighted there in red. And there's all these different levels to go through to complete this first playground. So quite an exciting time ahead there. As you can see at the top of the screen, it does say issuing commands. That's the level currently on. There's the left and the right arrow keys there to scroll through the different playgrounds if you wish to do so. The plus button just next to that title there lets you add in certain bits of code, or at least the sort of the layout for it, and then you write the rest, which we probably won't come to in the next few playgrounds anyway. And then the 3 little dots, again, just a little settings menu there, so you can take a picture and record it, broadcast it if you want to do that, and reset the page and other things there. Now on the right hand side of the screen, my iPad's in landscape, so mine's split left and right here. So in the top left hand corner there, you can see a picture of the red gem and then a 0, 1. So that indicates that there's 1 gem to collect in this playground. We haven't done so yet. The top right hand corner is the music icon, so if you wanted to, you can play some background music, some sound effects, and make it a bit more fun and easier to learn. So again, you can just toggle those on and off. At the bottom right, we have the hint button. You'll press that and it'll give you some hints. On some of them it'll also tell you the actual solution too, which can be quite handy. Just press the X and go back. You have the button to run the actual code there, so once you've written all your code you'll press that and it'll run through it. But this little sort of stopwatch clock icon here is a handy little feature. So it allows you to run through the code at different speeds. So it's defaulted just a normal speed, but it can run faster and run fastest. And that can be quite handy on a big level where you've got quite a bit of code to run through. It'll do it quite fast. But also you can go reverse and go a bit slower. And again, that's very handy if you're not sure or there's a mistake somewhere in the code you've written. It'll let you go through line by line. And of course when it goes wrong, you'll know what line of code there is wrong. So again, a very, very handy little feature there. Also, we can see the actual 3D world itself here. Now you can sort of pinch and zoom and move around and have a really good explore. So this character here, that's sort of stretching and blinking at times, is called Byte. So his goal is to move around the world and collect gems and toggle switches and things, as we'll see. And if you just notice as well, actually, from perhaps this angle here, I mean it's reasonably obvious, but just to make sure that you can see the island split into little squares. So Byte himself is on this square with the arrow on, or I could call it a tile. There's one ahead of him, then there's another one ahead of him that includes the steps, and then there's one there with the actual gem on. So like it's almost 4 different squares. So every time we ask him to do something like move forward, that's what he'll do. He'll move forward one of those tiles. So again, just handy sometimes to be able to sort of spin the world round, see exactly what's about, zoom in and have a really good look around. So the left hand side of the screen is really the main part. So this is where we're learning to write our code now. So when you look back in years to come and you're sat on your super yacht in the Caribbean, your £100 million yacht, and you're sipping champagne and you're thinking, where did it all start? Well, this is it. Your very first playgrounds writing Swift code that built your app that made you millions. So quite an exciting time here. So each level has a different set of instructions to follow through. And as you go through it all, you'll actually realise you've learned a lot more than you thought you had, but in quite a fun and exciting way. So we'll crack on with this first one now then. So it's issuing commands. The goal was to tell Byte to move forward and collect the gem, which we can see there on the right hand side. So it says in this first puzzle you'll need to write Swift commands to move Byte across the puzzle world to collect the gem. So there's just 2 commands here, and that's move forward and collect gem. So we have to write that code. Now if you click on that bottom part there under 3 which says tap to enter code, we'll click there and you can see another little bar opens up at the bottom here, I'm using an Apple Smart Keyboard here, so it's not obstructing the screen, but you might have your virtual keyboard now appear. So bottom left hand corner is just the undo and redo. Now the only commands on this level, the only bit of code to write really, is collect gem and move forward, and they do have auto suggestions, so you can just click on one of those and it'll write the code for you. Now personally, I would always say to type it if possible. And the reason why I say that is, again, it's one of those things you can't really get away from. So you can have suggestions here, that's great fun. But ultimately, when you're writing your app, you will write lots of code freehand using a keyboard. So sometimes it's good to get into that habit now, especially because you'll learn how to overcome typos and you've missed a bracket off or something, and you'll just get more into it. So if you want to just use those auto suggestions for the first few, while you're just very new, that's absolutely fine. But I would also suggest trying to type it. So, what we need to do now then is we actually need to look at the 3D world. So we need to collect that gem. So what do we actually need to write? What's the actual code? Well, we can see there that if we just zoom in again, if we asked him to move forward, he would move forward one square. If we asked him to move forward again, he would then climb those steps and stay on that square. And if we asked him to move forward again, he'd be on the square with a gem. So really, we're asking him to move forward 3 times. And if we do that, then he'll be on the tile there with the gem on it. And then we actually need to command him to collect the gem itself. So I would say then, let's see if you can get the same answer here, the code would really be move forward, move forward, move forward, collect gem. So shall we try that together then? So you can use the auto suggestion if you want. I'm going to type these in. So move forward. And again, already a spelling mistake there. So I'll move him forward 1. If we move him forward again, then he should climb those steps. And we'll move him forward 1 more time. And of course, then we want him to collect the gem. So I think actually, for this first level, that's our code written. So what we can do now then is we can press this button here, run my code, and we'll see exactly what happens. That's once, twice, 3 times, and collect the gem. And as you can see, that's congratulations, you've written your first line of Swift code. So again, as you go through this course, you'll learn it's not just remembering functions and names of functions, but again, it's actually thinking about things, problem solving. So we have to move him forward 3 times, not just once, and assuming he'll go right to the very end. So as you go through this course, you'll learn all the sort of little tips and tricks they're used by programmers. You can just click the next page in that congratulations box, and it'll take you on to the next playground. And I'll leave you here, and you try and figure out this out yourself. And we'll see you in the next lecture. Thank you. Hello and welcome back. So hopefully you've had some fun, you've learnt a few more things, you've turned left, you've learned how to toggle switches and go through portals. So now on this section we're looking at now finding and fixing bugs. And obviously this is quite an important factor when you're learning to code. So as it says there, when you write code it's easy to make mistakes. And again, I've done it many times. It's just you've used a capital letter somewhere, you forgot to use an open or closed bracket or something that's so simple, and it can be so frustrating and take a long time to find your error. I suppose it's like auditing accounts. Sometimes, you know, that 1 pence or whatever it is, that 1 cent, you just can't find it anywhere, and it's so obvious, it just takes you a bit of time. So when the code doesn't work, it's called a bug, and of course in the process of finding it and fixing it, then you are debugging the code. So if you look on the left hand side here then, the goal is to find the bugs and fix them. The first thing that actually advises us to do is to run the code to see where the mistake occurs. Now you can see when you enter into this little level, the code's already written for us. So we have to work out where this bug is. So it's asking us first of all to run the code. That'll help us to visually see where we're going wrong. So we'll do that now then. We'll run the code. And he's moved forward and he's turned left, and he's turned left too early, hasn't he? And now he's gone down. He's collecting a gem that isn't there. He's moving forward and he's trying to toggle a switch and is just completely confused. So looking at that code then, in the bottom left hand corner, we have move forward, then he turn left, then he move forward, and then it's again to move forward again. But of course he turned left too easy. So as it says in the instructions there, identify the command that's in the wrong place and tap it to select it, and then hopefully we can drag it to the right location. So I think that third one down then, move forward, needs to go above turn left. So we click on that and just drag it above. So now our code reads move forward, move forward. So that's on the right level. Enter. Turn left, that's in line with the gem. Move forward, collect the gem, move forward, toggle the switch. So hopefully that should be about right now. We've got that step turn left at the right place. So let's run the code. And it should reset it. Let's see what happens now then. So we've moved, now got on the right level. And here we go. We've collected the gem. And we've toggled the switch. So excellent. Congratulations again. You found the bug in the code. Again, that one was quite straightforward. But it's an important concept to learn and trying to remember that to debug code. And so it all works nice and smooth. So thank you. And we'll see you in the next section. So now we start our second section in this first Learn to Code playground number 1, and that is functions, and probably one of the more important aspects of coding actually, and that's grouping tasks together. So as we go through these slides here, it uses a very good illustration in a moment about grouping little tasks together. So as it says there, every day you perform a range of tasks automatically without even thinking about what you were doing. But even a simple task like tying a shoe took time to automate. So again, there's 3 images there, and you had to learn that sequence of what you was doing. So to learn, you had to loop, swoop, and pull. So it was 3 little sections there, or 3 things to do to achieve the one goal, which is tie your shoe. Now in programming, a function allows you to name a set of commands that will run every time. So rather than having to write down loop, swoop and pull every single time, you can create it in a one bit of code called tie my shoe, and then it'll run all 3 there together. So as you can see, you can define your name, so tie my shoe, it can be whatever you want, tie shoe, whatever, and of course then you've got the brackets at the end of that, and that's the function name, and then in the function you put all the different bits of code that you want that to do. So then you can just call your function name, which is tie my shoe, and then it'll run those 3 bits of code every single time. So that's basically a function. So it's a piece of code that lumps together several bits of code, and it can be run from anywhere in your app as well. So we're going to start coding. Hello, so here we are in this first part in the function section. So we have composing a new behaviour. So as we've learnt so far, we've just been turning left and moving forward, collecting gems and things. But as it says there, have you noticed there's no turn right available to you? So you can sometimes have to solve coding problems by combining existing commands to create a new behaviour. This process is called composition. So again, in this challenge here then, we have byte over on the far end of the world, and we've kind of got to move them around, haven't we? And we've got this right turn there in the middle. So how can we do that? Well, step number 1, figure out how to turn to the right using only the command you've used before. So I'm going to pause here a second, and let's see if you can think this one through. And again, it's using these problem solving skills when you're coding. So how can you turn right using only the commands that you've used so far in this playground? So did you get it? Well, if you've thought it through, obviously we can move forward, we can move forward, we can move forward, but then to turn right, we could of course turn left 3 times and then spin byte around and then moving forward again. So if you go into tap to enter code, we'll try this. So we will move forward, we will move, oh dear me, forward, and we will move forward one more time. So we need to move him forward 3 times. Then of course here we want to turn right. So if we turn left 3 times, and if you can visualize that in your mind, hopefully you can see Byte then actually facing the way we want him to face, which in effect means he's turned right. So again, once we've done that, of course, we need to move him forward again 3 more times and then collect the gem. And again, you can see that I'm typing all of these. If you're still using the auto suggestions, that's okay, but as I've mentioned in a previous lecture, I would really recommend typing. Just gets you used to writing these and finding the brackets on the keyboard and things there as well. And of course we need to collect the gem. So hopefully if we run this code, this should hopefully work. So we've moved forward once, moved forward twice, moved forward 3 times, turn left once, turn left twice, turn left 3 times, move forward once, move forward twice, move forward 3 times, collect gem. And there you have it. So you combined 3 left turns and that enabled your character, Mr. Byte, to turn right. That's called composition. Of course we haven't actually written a function in this little level, but as we move on to the next level you'll see you could then put those 3 turn lefts into a function called turn right, and that's what we'll do next by clicking the next page. So see you in the next lecture. Hello and welcome to the Creating a New Function playground. So as we can see here, the goal is to define and use your own function to turn right. So we're actually going to be writing a function here, and actually I think that's quite exciting because writing functions are one of the key parts of any computer language, but of course especially learning Swift here. So this is your first opportunity, this is the first function that you will write. So first of all, let's look at the right hand side of the screen. Let's just explore the world that we have here with Byte in it. And of course we can see at the top of the screen there's these toggle switches. 2 of 3 are already done, so we only actually have to toggle the 1 switch. Now to get to that switch on the other side we have to go through that portal, and of course that will involve turning right. So it says there on the left hand side of the screen, in the previous puzzle you turned right only once, so having to turn left 3 times wasn't really a big deal, was it? But of course in real world situations, and of course in more complex playgrounds, you might need to turn right more than once. And of course then it makes sense to put that code into a function and then just call the function when you need to use it. So that's what our goal is here. So what we can do, if we just scroll up there on the left hand side, so first of all it's already auto generated the function outline for us. So as you can see, functions in Swift always start with F-U-N-C, function. Then you actually name the function, which is turn right with the open and closed brackets. And you have the opening curly brace and then the closing curly brace. And all the code you put in the middle becomes part of that function called turn right. So let's just split this one down a little bit first of all then. So let's just write the function first. So to turn right, what code do you need to write in that function? And I'll just pause it for a minute and let you see and work that one out for yourself. So did you get that alright? So of course we need to click on that box, add commands to your function, and actually it's just exactly the same as we did in the previous playground. So it's turn left, and it's turn, oops, so I can spell correctly, turn left again, and of course turn left 3rd time. So that now has written our function. I see that red dot has gone away, which was an error, so that's fine. So that's the function written then. So every time we want to turn right, it'll now run these 3 lines of code called turn left. So the other part of the goal is actually go to that bottom box, and that's where we're actually going to write our code to make this whole puzzle work. So again, let's look at the world on the side here. So really we need to move byte forward, we need to turn him left, we need to move him forward, turn him right, move him forward, which then move him down the steps, and then he'll be on that one with the switch on, but it's already turned it on anyway, so there's nothing extra to do there. Turn right and move forward. That'll put him on that square there with the portal on it. He'll zoom to the other side, and he'll face the same way as he went in. So again, move forward, turn left, and then to toggle the switch. So shall we write that code together then, and see how that works out? In fact, if you want to give it a try yourself first, I'll just pause again for a few seconds, and then we can continue writing it together. So here we go. So we want to move forward. We want to turn left. We want to move forward. And then this is the first instance here where we want to turn right. So actually when we write turn right, what it'll then look for when it runs the code is that function above called turn right. So then it'll know actually turn right means turn left 3 times. Right, so we want to move forward again, then turn right, move forward again and turn right. Hopefully you're getting the hang of these puzzles now and you've been able to see these little patterns and how to move them about. Again, that's our second call, that function, or third call to turn right again. Then we'll move forward. We will turn left. And we're right at the end of the puzzle now, hopefully. So we'll move forward. That should take us to that last switch to turn on. So in the case, it's just a case of toggling the switch. So hopefully that should now work. So we've got our normal code like we've been doing in that bottom box, and of course each time it says turn right it calls the code and that function called turn right. So let's run the code and see if it works. So move forward, turn left, move forward, and it's turned the left 3 times to turn right, of course, and it's doing it again 3 times now. Let's move forward to the portal, and it wants to turn the right way, and there you go, it's worked. So again, as it says there, you just wrote your first function, and like I say, in most computer languages a function is one of the absolutely key parts of it. So the fact that you've done it now is absolutely great. You should be really proud of yourself. Just give yourself a pat on the back or say thank you and well done to yourself. You've just written that function. So hopefully you understood that and continue on into the next playground. So here we are then with our new section, for loops. So in the previous section you learned how to use functions, and hopefully now you are quite confident with that. Now we can move on to these loops, which is obviously repeating yourself. So let's just move through these slides as it explains exactly what a for loop is. So using this example of gardening here, so imagine you're helping someone plant seeds in a garden. You can see there's 4 flowers there in that flower bed. And of course they might say, for each of these 4 seeds, you need to make a hole, you need to place a seed down the hole, and then move forward 5 inches, so there's a bit of room there, and then do the same thing again. So to write a for loop, use for and include the number of times the loop will run. As we can see there, that's now the example. So then it becomes for each seed in 1 of 4, which means you want to run it 4 times, make the hole, place a seed, and move 5 inches forward. As we can see there, the make hole, place seed, and move 5 inches forward. Then there are actually lines of code that can be run inside that function. and because it says 1 in 4, it'll run 4 times. So hopefully that makes sense and when it comes to coding. So of course at times you'll run code several times, and that's all what a for loop is actually running that code as many times as you need it to run. So let's click on start coding then and go into the first one. So here we are then, the first playground in the loops section, which is using loops. So as you can probably see there, it looks quite complicated on the right hand side of the screen, but what you'll notice is when we complete the playground is how little code you have to write to complete it, because we are now using loops. So it really does make the code nice and smooth and easy. So it says there the goal is to use a loop to repeat a sequence of commands, and of course we'll call the functions in that loop there as well. So first it says enter the solution for one row inside the curly braces, decide how many times you want to repeat the loop, and I'll put that number in the placeholder in the for loop there. So if you look across at the right hand side of the screen, we'll just spin around and zoom in so we can see what we're playing at here. So we have byte there, and we can see these different portals to go to the same colour. So the blue will go to the blue, green to green, purple to purple, yellow to yellow. And so what we can actually see really is just we need to do one row and then call that as part of the loop. So if you want to have a quick think for a couple of seconds, I'll just wait and see if you can sort of work out what we need to do here. So what I think then is we need to move byte forward. We need to move byte forward again, collect the gem, and then move byte forward one more time. Then you'll be on that blue portal, and then you'll start the next row. So the next row, so the first row, the next row starts with the blue one, the next row starts with the green one, next row starts with the purple one, and the last row starts with the yellow one. So we need to run that code 5 times, I believe. So if you look at the code on the left hand side of the screen, for I in 1 in how many times? Well, if we write 5 times there, if we click on that, and we'll write 5 times, and then tap to enter code, we'll just write that simple code. So I believe it's move forward. We want to move forward again, and of course if we just spin that around again, that'll move into the square where the gem is. So then we want to collect the gem, and then we want to move forward one more time, and hopefully that'll move them to the square with the portal on, and then that'll code it will then run 5 times. So let's now press run the code and see if it works. So it ran it once successfully, and now it's going to run that loop, that code 5 times. This is the 3rd time now. So again, it's just move forward, collect gem, move forward each time. And this should now be the last time. We said to run it 5 times, so it shouldn't run again. And it'll move forward to that last square. And congratulations again. So actually, when you look at the left hand side of the screen, you've actually written 4 lines of code, and yet it's collected 5 gems, it's gone through 5 portals, and it's moved forward quite a few times. So it really does simplify your code and make it a lot easier when you use loops. So nice work, and if you move on to the next one, and give that one a try. So welcome to this challenge now then, looping all the sides. So in the previous challenge, you actually looked at writing loops, and we ran that code 5 times, and it moved down each row, didn't it, and collected all the gems and went through all the portals. But of course, the actual code is already there for you. You just have to write the actual function part into the loop. So in this challenge, we're actually going to write the loop itself. So it says there, it's nice and straightforward actually. In fact, if you look at the right hand side of the screen, we can kind of work it out. So the code's already written for us. Move forward, collect gem, move forward, turn right. And of course, if it does that, then it's done that whole side of the puzzle. And of course each side actually is identical. So the gem's always on the second tile, and of course you want to move forward to the end and turn right, second tile again. So again, it's a nice example to write a nice loop. So the code's already there for us, and we just need to loop it around as many times as we need to. So if you can have a quick think of how to do that, and I'll just pause for a couple of seconds, and then we'll actually follow the instructions there in the challenge. So did you have a think about that? Well, it's actually nice and easy because the code's already written for us. We just need to add the loop around it. So as it says there, number 1, so it says tap 4 in the shortcut bar to add a for loop into your code. So if you bring up the shortcut bar and press the 4, that'll actually write the function itself. And of course, how many times we want that code to run? Well, again, have a think about it. There's 4 sides, they're all identical, so we want that code to run 4 times. We can click 4 there and then go back into the code. Now number 2 says tap the bottom curly brace to select the loop, and now it's done that and highlighted in red, and then tap and hold that brace and drag it down so all these little functions here get included within that loop. If we let go, we can actually see now, can't we, for each I in 1 and 4, move forward, collect gem, move forward, move forward, move forward, turn right. And it says 1 and 4, so we'll run that 4 times. So hopefully the will go around the whole board there, the whole world, and collect these 4 gems. So let's give that a try and run the code. So move forward, collect gem, move forward 3 more times, and then of course turn right. And then it'll loop the code now as we've instructed it to. So this is the second of 4 times it's doing it now. And of course it'll go right round and run that code 4 times. So again, another example really of using loops, how little code you actually need to do it to do quite a lot of things there. So we've moved them right around the entire world, we've collected 4 gems, I've actually only written 6 lines of code to do so, and it's all there in that loop. So it says excellent, it's now done, and of course now move on to the next challenge and give that one a try yourself. Hello and welcome to this next section in our playground, now introducing conditional code. It says there, how do you plan for the unexpected? So actually conditional code is a really important part of any coding language, including Swift. But actually we have some good news here. If you're used to using spreadsheets and things like Microsoft Excel, you may already have a bit of a head start. So if you're using Excel a lot and you know how to write an if statement, then really that is conditional code. So for example, in a spreadsheet you might say if A1 and A2 equals $10 or £10, then in A3 show under budget, else if they equal more than that, then show over budget. So again, it's this if statement with a true and a false part to it, and then a different outcome either way. So if you are used to those sort of statements, then you do have a bit of a head start here. But of course, let's now run through these slides and get a good overview of what conditional code is in Swift. So it says there, if you hit a traffic jam, you may need to change your route. So this is depending on the circumstance, and then be able to do something a bit different really. So as it says there, in code you plan for different circumstances using an if statement. So the light's green there, so if the light's green, bike walks forward across the street. And that is how you write an if statement in Swift. So you can see if, and then the name of the function you want to call, or name of the if statement, light is green, and then the opening and closing curly braces, and of course what's in the middle there is the code that you run. So it's nice and easy. An if statement just starts with if. And as I can see there, then the walk forward is the function. So if light is green, then run this code called walk forward. And a good thing with an if statement is you can also specify what to do if it's not the case. So we have if light is green, walk forward, and then else, and then again the opening and curly braces, and then you put your code in the middle there, then to run that function called wait, because it's not green. So that's what it means there. If light is green, walk forward, else, and else means the light is not green, then wait. So hopefully that was a nice easy introduction to conditional code. If we press the start coding button, we'll go into the first playground in this section. Right, so exciting times here then. We're now in the first playground in this section, checking for switches. And as it says, the goal was using an if statement to toggle only closed switches. So actually reaching quite an exciting part really in coding, and that is if statements. So again, just explore that world on the right hand side. It's very simple, as it's the first playground in this section. We can see there's 3 switches all ahead of him, and we have to toggle them all on. But there is something a bit different here though. If we look on the left hand side of the screen, it says try running this puzzle a few times before you write any code, because what you'll notice is those switches will randomly change between on and off. So if you press run my code now, before you've even run any code, now we can see there's all off before, now 2 of them are turned on. If you press run my code again, they'll reload in again. This time they're all off again, and so we can't just write a set bit of code to just toggle them on and off. We actually need to write a code to make sure if they are off, turn on, if they are turned on, then leave on. So a nice little challenge really Apple's put in this little playground for us here. So as we can see there, we're introduced to a new condition, and that is on close switch. So we can put that in the if statement, and if that is the case, we can then toggle the switch on. So hopefully that makes sense. That example there on the left hand side, if is on close switch, toggle the switch. Now in the introductory lesson, we also put an else in there, so if it wasn't true, then to do something else. But of course in an if statement that isn't necessary. So that will just run only if that condition is true. If it's not true, then it'll just simply ignore the code, or not ignore the if statement, and just move on to the next line of code. And that's what we're going to do here. So again, if you look on the right hand side of the screen, and if you just have a few moments yourself just to think about how you're going to go about doing this, see if you can get it in the right order and the right code, and then we'll run through it together. So I'll just pause for a couple of seconds. So did you get that then? So by my reckoning, of course, we need to move forward. We need to move forward, and then we're on a square with a switch on, and then we need to run that code to see if it's a closed switch and turn it on, because of course every time we run that code it's going to be different, so we don't actually know it's going to be on or off until we actually run the code itself. Then of course move forward, and then the same if statement again, then move forward, and then the same if statement again. So let's try and give that a try. So tap to enter code. So the first 2 lines are quite straightforward. Move forward and move forward. Then we want to write this if. So if is on closed switch. Then we need to put in there the code that we're then therefore you're quite used to. Oh, I can see I made a mistake here when I'm typing. It wants to be a capital C, and we want to toggle the switch. So as we can see then, that means when we run that code, we won't run it, but if we do run it, it'll move forward to that first switch, and then if it is turned off, it'll turn on. But of course, if it is turned off like it is now, then it won't do anything. The code doesn't say to do anything at all, so it'll leave it as it is. So then we need to move forward again to the next switch, of course. And then we want to actually just write, basically, the same if statement. So is on closed switch. Oops. And put the right braces in there. Then toggle the switch. So that's now the second switch. Again, of course, we need to move forward to the last switch. So those switches are always on those three squares in this particular challenge. The only variable is you don't know if they'll be turned on or off. So again, then it is if is on closed switch, then toggle the switch. So hopefully that makes sense. And if we look at the code, we're moving forward to that first one, so move forward twice. Then we're asking if it's turned off, then turn it on. And if it is already on, then basically do nothing. It goes to the next line of code, which is move forward, which then moves to that second switch. And again, the same pattern for the second and third switch. So when you run the code, you'll see it load back in again, and it'll randomly turn off or on some of those switches. But the code you've written should make sure that they're all turned on by the time you get to the end. So let's do that. Let's press run my code and see if this works. So it's reloaded them back in. It's actually reloaded them back in all off, which is interesting. So the code says if it's off, then turn on, move forward. If it's off, turn on, move forward. If it's off, turn on, and it has done. So you've just written code that works even when you didn't know if the switch was toggled on or off. And again, as I say, if statements, conditional code are a very powerful part of any coding language. It really opens up the code and what you can do with it in a very important way. So hopefully that makes sense. It's quite straightforward in this first playground, so if you move on to the next playground and see how you get on with the next few. So in the last lecture we learned a powerful lesson using if statements, and here we're introducing that second part really, and that is the else part, or in this case actually the else if part. So you can have more than two parts to it. So if you look at the goal, it says use if and else if to toggle a switch or collect a gem. And again it says to run the puzzle a few times because they will randomly change. So if you look on the right hand side of the screen, we can see byte, and just basically two squares in front of him are two gems. Now if you run the code, those two squares can change to something completely random. So now it's a switch and a gem. If you just run it again, it'll reload it again. This time it's two switches. So again, they're always going to be on those two squares, but you'll never know if they're going to be a switch or a gem. So we have to write an else and an else if to run the code to either collect the gem or toggle the switch, which we can see there in the example on the left hand side. So we can see if is on closed switch, toggle switch. That's what we did in the last part, but this time the else part, else if, and a new condition called is on gem, then we want to collect the gem. So basically it's move forward and then run the code to see whether it's on a switch or a gem. If it's on a switch, turn the switch on. If it's on a gem, then collect the gem. So again, just leave you for a few seconds just to see if you can think exactly how to write that out, and then we'll do it together. So did you work that one out then? Well, of course, if you go tap to enter code, the first thing we need to do, as we usually is we need to move forward. That'll move forward onto that first square then, where it's going to be either a gem or a switch. So to be honest, the code is exactly the same as the example noted above there. So if, and like in the last playground, is on a closed switch, then we need to toggle the switch. And if you go to the end of that second, let you open the curly brace, and then write in the next part, which is then else if, and the condition is if it's on a gem, so is on gem, Now we need another new set of open and curly braces there. And we can run the second bit of code, which we're well used to now, and that is collect gem. Which again, that red little dot throws up the error, and it's because I didn't put a capital G, so that makes sense. Very good. So just look at the code before I write the next bit. So we've moved forward. So now we're on that first square. Now that first square, when we run the code, could be anything. It could be either a gem or a switch. So we're saying if it's on a closed switch, then toggle the switch and turn it on. If it's on a gem, then collect the gem. And just to give you a bit of a hint here, the switches will always be turned off on this particular challenge. So there's no if it's on or off, and then if it's on a gem and collect the gem. It's always going to be off. It's always going to be just toggle switch if it's on a switch. And then really, to move on to the next one, you just really copy in the same bit of code again. So moving forward now onto that second tile, and again it's exactly the same. We're saying if it's going to be on a closed switch, then we need to toggle that switch. But of course we don't know for sure that it is going to be on a switch, so we can say then, well, else if it's on a gem, then we also want to do something with that, because we want to collect the gem. So hopefully now then, when we run that code, regardless of how it loads up, whether there's going to be a switch or a gem in front of us on either square, it will either turn the switches on or collect the gem. So let's press run my code and see if that works. So this time it's both gems have loaded in. So it's not on a closed switch, so it's ran the else if it's on a gem, and again it's also ran the else if again. So now you know how to write your own else if statements. And again, a very important part of learning how to code. So see if you can move on now in the next few playgrounds as you continue to learn more about else and else if statements, and give that a go yourself. And thanks for listening. Hello and welcome to this next section of the course, and that is logical operators. Could you be more specific? And I must admit, from now on the course does get a bit harder, I think. A few more things to think about. So in a logical operator, in this section, it's either going to be if a condition is true or false, but also add in the options of can both conditions be true then do something, or if one of the conditions be true then do something with the code. So it's asking us there to be more specific. So what we'll do then, we'll run through these slides. You'll notice there's 10 this time, and hopefully we can get the three different types of operator we're going to learn about here. So if you remember the introduction video to the last time, to the if statements, conditional code, it was by walking across the street. So if the light's green, walk forward, else then we need it to wait. And of course encoding operator is a symbol that represents an action, so the 2 + 4 is 6, and you have the operators there. So this is the important screen to remember really. These are the 3 different types of operators we're going to learn about here. So that's and that's represented by the 2 and symbols, or the proper name is ampersand, the 2 ampersand symbols. Or is the 2 line symbols there, and you're probably looking now on your keyboard to think where are those symbols, and it's next to the brackets and braces, open and close one there. Or not is an exclamation mark. So go through each of these. So the logical and, the code runs only if all the conditions are true. So the example there, if we're blocked on a particular tile and we're on a gem, then collect the gem and turn round. So that collect gem and turn round will only run if we're blocked and we're on a gem, as we can see here with the full coding properly there. So if it's blocked and if it's on gem, collect gem and turn around. Now of course this one here, this code runs if at least one of the conditions is true. So if we're on a gem or on a switch, then do a dance. as we can see there with the code, we're now saying if is on gem or is on switch, then do the dance function there. So it could be, of course, we're not on a switch or we're not on a gem, but that code will still run if one of those conditions is true. And the not operator is quite an unusual one, although you start using it all the time once you've got used to it. And that is just to put the exclamation mark at the front, which changes it to false. So if you remember in an if statement, we're saying if the light is on green, then do this. So that means the first part of the if is always the true part. Using the exclamation mark, you can really make it the false part. So if exclamation mark, as it says on the screen here, is on gem, that makes it actually saying if we're not on a gem. So almost like a double negative, really, which is quite an interesting way of writing it, because of course we might want more of the conditions to be in the true part. So here's that example. If is blocked, but now is blocked as an exclamation mark. So what we're actually saying is, if we're not blocked, then fly away. So the not operator changes the condition is blocked from false to true. So hopefully you've got that, and I think the next few playgrounds will be quite challenging, but again, this is really the point now where your coding skills are really going to ramp up quite fast, and you look back and then you'll think I've actually learnt quite a lot in that section. So what we'll do now, we'll press start coding and we'll go into this first playground using the not operator. So hello and welcome to this first one in this section using the not operator. So it says there the goal is use the not operator to adjust your character's path when there is no gem on a tile. If you remember in the introductory lecture, the not operator is the exclamation mark and it inverts the value, changes it from false to true. Now that actually is a Boolean value. Now you might have heard of that, Boolean algebra. It was named after a mathematician called George Boole, and he's actually from Lincoln. So literally 2 miles from where I'm recording this lecture now is where he was brought up and went to school in Lincoln. I think he moved on to Ireland after that. But he developed his logic of true and false, and that's used worldwide now in computer code, a Boolean value or Boolean logic. So it says there, it says run the puzzle a few times to see what changes. So as we can see at the moment, if you look at the right hand side of the screen, we have a gem, then one down a set of stairs, a gem and a gem. So in this challenge, there's always going to be the gems ahead on that row, but where the staircase and the gem is will change each time. So just run that code. So it's on the second one at the moment, and it's rerun in that second one. Of course the code just moves it forward at the moment anyway, as you can see there. So just run that one again, see if the staircase moves. This time now it's on the first one. So if you want to have a think about how we can achieve this, you'll see in the left hand side as well, already in the code, there is a for loop written for us. So it needs to run a code 4 times. And as we can see, if you have a think about it, what we need to do. So if you just go back to the start again, in fact I'll just move to a different lecture and load it back in again, because that's throwing me a little bit. So Byte's at the start here then, so what we need to do is we need to move him forward, and if he's on a gem we need to collect the gem, and if he's on a square where there's no gem, that means that's where the staircase is. So you need to go down the staircase, collect the gem, come back, and then keep moving forward and collecting the gems. That's why that for loop's written for us there already. So if you ever think about how to do it, I'll just pause for a few seconds and then you can give it a go. Right, did you get that then? So if you click into the code here, so of course the first thing to do, as it usually always is to move forward. So we'll just move that end curly brace down a few lines, because this is where all the magic is now going to happen. So basically we just need to check if it's on a gem, collect it and move forward. If it's not, then go down the staircase, collect it and come back, and then carry on down that track. So we start, and of course we're inverting the value here. So it's not if is on gem, It's now if exclamation mark is on, sorry, I spelled is wrong, is on gem. And then we need to have some curly braces again, and then we want to run the code that runs through if this is case. This is really an if statement built into this loop here. So we're saying if it is on a gem, then do this. But by putting that exclamation mark in, we've changed it to the inverted value. So now we're saying if it's not on a gem, then we want to go downstairs and collect it. So of course we would need to turn left. We need to move forward onto the one at the top of the stairs. Move forward again, and that'll put us on the square with the tile on. And of course then we want to collect the gem. Then we need to make that turn and go back up the stairs again, so it will be turn left twice. That's now turned us around, but we're still on that square with the gem on at the bottom of the stairs. Oops. Oh, I've written left. That's very odd, isn't it? This is how the brain works sometimes when you're writing a lot of code. And of course, then we want to move back forward again. So now he will climb the stairs, and if we will move forward again, he's back in that original starting row now. And of course, we need to turn left so then it's facing the right way. Now, of course, so we're saying that code is going to run if he's on a tile that does not have a gem on it, because we've inverted is on gem to basically is not on gem. But of course, if he is on a gem, then we want to just basically collect the gem. So we're still writing an if statement here. So now we've got the else part, and again some more curly braces. And we're basically saying here, well, if there is a gem on that square, that means the staircase isn't there, and we'll just simply collect the gem. And you can see there, we've got that last bracket. So let's just look at that code a minute then, and see if you understand it. So it's saying for I in 1 and 4, move forward. So it's a for loop. This code is going to run 4 times. And the code it's going to run is this. If is on a gem is not true, so if there's no gem there, then I want to turn left. I want to move forward to the bottom of the stairs, collect the gem, turn left, move forward, back again, and turn left to face in the right way. Of course, if I am on a square with a gem, I don't really want to do anything else but just collect the gem. So as we can see here on this one at the moment, when that code runs, it'll ignore that first part of the if statement because the first square has a gem. So it'll just collect the gem. Then it'll run the code 2 in 4 in effect. The second time it runs the code. This time there is no gem, so it'll run all that code, and then it'll just run the else bit for the 3rd and 4th time. So hopefully you got that. I'll just click run the code and see if it works through. We'll see if it reloads in again. So now it's the first staircase this time, so it's got to that first tile, said is it on a gem? No. That must mean the staircase is there, so I'll collect the gem first down the bottom of the staircase. Now I'll come back, I'll turn left. Now it's running the code for the second time. Of course it's just a gem now, so just collect gem. Again, just a gem now, so collect gem. And again, just a gem now, so collect the gem. So it says you're amazing, and you really are. If you figured that one out, that is really good. As I say, the course will get a bit harder now, and a bit more thinking about it. So if you figured that one out, that is absolutely great. So it says there, using the logical not operator, you reversed a Boolean value, allowing you to check the opposite of a condition, like is on gem or is on close switch, which we haven't done in this particular playground. So what you're saying is, if I'm not on a gem, then do this. So it's an if statement using a not operator and a for loop. So it's not just one thing you're learning there actually. You've combined previous knowledge of loops and ifs, and now you're introducing this not operator at the same time. So that's what made it a bit harder. So well done, and move on to the next playground and give it a try. So in this playground then, checking this and that, we're now being introduced to the AND operator by the double ampersand symbol. So as it says there, the goal was use the AND operator to combine 2 conditions and adjust your path if both are true. So the AND operator says if this condition and this condition is true, then do this. And of course we're going to write this into an if statement, and if it's not true, then just do that. So if you look at the 3D world at the side, you'll see that there are 6 gems to collect, 4 switches, and 1 is already toggled. And again, basically in this world it doesn't change, so we know that's the fixed layout of the gems and the switches. So basically Byte's here in this row, we've got 7 squares ahead of him, and we have to just collect all those gems and toggle all those switches using the AND operator. So again, if you look on the left hand side there, it says we've got a new condition, and that is blocked left, a boolean value which we can set to true and false. So what we're saying here is, if you look at the bottom where the code is, there's already the for loop already built for us. So we're going to run this code 7 times, each time we're going to move forward and then check, and we can collect all the gems and toggle the switches. So like in previous lectures, we're using a for loop, which we've learnt earlier on in the course. We're using an if statement, which we'll use earlier on in the course. The only thing new here really is this AND operator, these 2 ampersand symbols. So if you have a look at the world and think, how am I going to achieve this? As the for loop's already there a little bit anyway, so we're going to move forward. So every time we move forward, we want to see, am I on a gem? If I'm on a gem, collect it. If I'm in a situation where I'm on a gem, I can't turn left, as you can see in this part of the world. So that happens 3 times in this world. So it moves forward, he collects all the gems, but he enters a point where he's on a gem, he can't turn left. That means there's a switch on the right. So the condition there is combined then. So we're saying if he is on a gem and he can't turn left, or he's blocked on the left, then collect the gem on that square by all means. But then it means there's a staircase to the right, go up there, toggle the switch, come back down again, and carry on through the code. So we'll just give you a few seconds just to think about how to go about achieving that, and then we will do it together in a moment. Right, so if you click on that code on that side, so as always the first thing we need to do is move forward, so that's absolutely fine. I like to just move that last curly brace out of the way a little bit, so we've got a nice big gap here of the code that we now need to write, which will run when each loop's been done. So again, as we mentioned, it's an if statement again, that's absolutely fine, and we're saying if Byte is on a gem, and this is really to toggle these switches, that's what this code is doing here, those ones that are already off, and we're saying if he's on a gem and an ampersand ampersand, which means and, so if he's on a gem and is blocked left, oops, then what we want to do is we want to run this code as part of the if statement. So this code will only run on those tiles where there's a gem turned off at the end. So of course that means we're actually on a square with a gem on it already, so the first thing to do, and the easiest thing to do, is to actually collect the gem that's on that square. Then of course we need to turn right, so then we're facing the correct way, and then move forward twice to reach the square with the toggle switch on. And then of course when we're on there, we want to toggle the switch. Then of course we want to make the return journey, so we need to turn around and move forward again a couple more times, back to that row, and then make sure we're facing the right way by turning right. So to turn around, we're going to turn right a couple of times, now we're facing the right way, and then want to move forward a couple of times to get back to that main row. And then of course when we're on that main row, we want to make sure we're facing the right way, so next time that for loop runs and moves forward, we are just continuing down that line. So that's the code then, if we're actually on a gem and it is blocked to the left. So we need to continue with the rest of the if statement, so we're saying, well, if that's not the case, if I'm not blocked to the left and I'm on a gem, then simply I just want to go away and collect the gem. And hopefully then that should run absolutely fine. And I've just noticed we do have a red dot up here, so if I made a mistake somewhere, I'll just click on that. Oh, of course, I've put the open and close brackets after is blocked left, which of course is absolute nonsense. And it even brings up that fix option there, so I can press that and I'll just delete those out of the way. So I actually did that on purpose, actually, just to show you how to fix problems. So rather silly of me. Anyway, so if we just look at the code we've written here then, and then we'll run through it, and then we'll actually run the code itself. So we're saying 7 times we're going to move forward, and then we're going to go through this if statement. So basically move forward, so that first tile, then we're saying if we're on a gem, and if we're blocked to the left, then collect gem, turn right, move forward, etc. But of course on that first tile that's not the case, because we are on a gem, but we're not blocked to the left. Then we're just running the else part of that if statement, just simply collect the gem. Then we move forward again. That on the next square there's nothing, so then it'll just move forward again, because there's no thing in the if statement to allow for that. And of course once we move forward 4 times, so on that third gem, it'll say if we're on a gem, which we are, and we're blocked to the left, which now we are, then we want to collect the gem on that square, we want to turn right, go up the stairs, toggle the switch, come back down, and face the right way, and of course then it'll run that for loop again, so it'll move forward and run that all again. And of course anytime we're just on a square with just a gem, we just want to collect the gem. Nice and simple. So let's run the code then and see if it works. So we've collected the gem, just move forward. Move forward again, collected the gem. This is the first key part here, so yes, we are on a square with a gem and we're blocked left. So collect the gem, go up, toggle the switch, double back round again, come back, and then run the code again. So collect the gem, move forward again, and this time we're blocked and we've got a gem, so we should go up there and toggle the switch. And of course next time will be the same situation again as well. Just make sure that works. They should toggle this last switch and it'll turn back and face the right way. And of course once it's done that, the code then runs 7 times. So then it ends. So awesome work with the logical AND operator. So we can combine now multiple conditions, make sure that they're both true, and if they are, we run a certain block of code, and if not, then we're doing something else, which in this case is just collect the gem. So hopefully that's okay. If you move on to the next playground, and you'll learn the last part of these logical operators. Hello and welcome to this section here then on while loops. So you may remember earlier on in this Learn to Code 1 playground we looked at loops, and would say, you know, for 1 in 7 etc. this code runs, which means the code would run 7 times and loop through it each time. But of course sometimes we might want to run code just for a specific period of time or until something is achieved, and that's when we would use a while loop. So while the condition is true it will work, and when the condition is not true it'll stop looping through that code. So what do I mean by that? Well, let's go through these slides now then, and it gives a good illustration here. So when you're hammering a nail, you can't just hit it a certain number of times and expect it to go all the way in. So of course you could put 3 nails on a block of wood, and it might be a different amount of times you hit the nail each time, because of course there could be a knot in the wood, or you might have hit the hammer not as hard, or perhaps at a wrong angle or something. So you can't just say it needs 5 hammers to do each nail. So as I said there, you continue hitting the nail while the nail is sticking out, which of course makes logical sense. So what you can do is you can use a while loop then to repeat a command, or a set of commands, while that condition is true. So it's given us the example here with the code, so while nail is sticking out, then run that code in the curly braces, hammer nail. So we'll just run through that. It'll keep hammering that nail in for as many times as it needs to do it. But of course now, when we go through that code again, it says while nail is sticking out, hammer nail. Well, of course the nail is no longer sticking out. So that condition now becomes false. So of course then it doesn't run that code. So a really nice little introduction there into using while loops. So basically it's like a loop, but rather than predetermining the amount of times it'll run, it'll just continue to run while a certain condition is true. So hopefully that's a nice introduction. If you press the start coding button, and we'll go into that first playground. So here we are then, running code while. So the first lesson here in our while loop section. So it says there the goal, use a loop to keep moving while not on an open switch. So as we can see on the right hand side of the screen there, this little world of bytes is very simple and straightforward, just one single row, and basically you want to make sure all those switches there are turned on. So how can we do that? Well, it says there, it says choose a boolean condition for your while loop to determine when it will run. A boolean condition is something that's true or false, and of course add commands to the loop to toggle open all the switches. So I'll just pause for a few seconds just to see if you can think how to do this. What I will say, just to give you a bit of a hint, is that it's surprising how little code you have to run here to go through this whole sequence. So I'll just pause for a few seconds. So did you get that then? As it says there, we have to choose a condition first. So where it says while and condition, we need to choose something here. So I'm going to say while we are on a closed switch, that will be my condition. Then I want to run this code. So tap to enter code. So while we're on a closed switch, of course what I want to do then is to actually turn on. So I want to toggle the switch. And of course each time I've toggled the switch, we've achieved what we need to do on that particular square. So of course we just need to move forward. And of course when you think about it, if you look at that code, that means it'll move forward. I'm going to close switch, yes, toggle the switch, move forward, and it'll just keep going through that whole sequence. So really just 3 lines of code, hopefully, and we should be able to achieve success in this little world here. So I'll just click run my code, so make sure it works fine. So we're on a close switch now, so it toggles it. Yeah, we're on a close switch now, so it toggles it. We're on a close switch now, so we toggle it. Of course, this last one's already on, so it should do nothing, and that's it. So it didn't take you long to figure out how to use a while loop. And of course, basically what we've done there is we've turned 4 switches on, we've moved forward with it 4 times, and we've written just 3 lines of code. So really quite a powerful thing here using a while loop. You can really achieve a lot of things just with a few lines of code. Also, as we continue to move through these different playgrounds, you probably started to think about other things as well sometimes, and while I've kept the code to the basics for that particular challenge, you could have started writing functions and other things in too. So if anyone out there chose to change that is on close switch with a new skill that they've just learnt, for example, we've just learnt in the last section about logical operators, so we could have actually used the exclamation mark, which is the not, and then is on open switch. So of course that code would mean exactly the same. So again, don't just always follow me, because for us in coding there's always several different ways of trying to solve a problem or a different condition you can use there. So hopefully you remember that from the last section on logical operators. Exclamation mark is on open switch is really exactly the same as what I chose, simply is on close switch. So again, try and have a bit of fun with your code, explore around it if you want to, and that'll help you to remember some of the other things you've learnt in the previous playgrounds. But if you don't want to, that's fine as well. Of course, we're just learning one thing at a time here anyway, so that's fair enough too. So hopefully that's okay. If you now run through a few more playgrounds, and we'll close out this while loop section. Hello and welcome to this playground turned around, and probably the most exciting playground I've had to date, because the challenge there is choose the tools that will make your solution as efficient as possible. So I've actually been asked here to combine everything we've learned so far in this course to write probably the shortest amount of code to achieve the goal. So if you look in the right hand side of the world here, we can see byte, and there is 8 gems to collect, and you can see it's on a square really of 4x4, and in the middle 2 of each side of the square there is gems each. So you can probably already thinking, well, what pattern's there? Well, you're probably going to run some sort of code 4 times to collect all those gems in an efficient manner. So it says there in your coding tool belt you've got functions. You can use for loops, conditional code, the logical operators, not, and or, while loops. It says for this challenge your goal is to choose the most appropriate tools from your coding tool belt to create a solution for the puzzle. But here's the key bit: there are no right or wrong answers. So just try to be as efficient as possible with your code. So really on this challenge you really want to spend a few minutes, I think, really putting a bit of thought into this, and how can I achieve this in the simplest and efficient way. So again, think of those things that you've learned, functions and loops and conditional code. You don't have to use all of them, of course. You may just choose to use 1 or 2. But see if you can come up with a solution, or perhaps even 2 solutions, to help Byte collect all these gems. So I'll just pause for a few seconds while I have a think about it, and then we'll go through it together. So did you get that then? Well, I'm going to go into tap to code. I'm actually going to, the very first time I ran this, I wrote some code, which I'm now going to paste in, and have a look at that. So what I actually did here, in my mind, I thought, well, I can create a function called each section, because we're running this code 4 times, and then the sequence of code we want to run each of these 4 times. So I created that function, each section of that square. So where I am now, I want to move forward, I want to collect the gem, I want to turn left, move forward, collect the gem, turn left, move forward, turn right. And of course, once I've done that little sequence of code, I'm then really facing the right way, ready for the next segment or quadrant of this square. And of course, then I just wrote a for loop there, so just run that code, run that function really, called each section 4 times. So if you run that code, then that will work, it's absolutely fine. But of course, I haven't really been very explorative there. I've just used a function in a loop, not really thought about it a lot, and there's still a bit of code there in that function, which is a bit sort of messy and long-winded. So what I'll do now then, I'll just delete. Actually, I can just undo. Oh dear me. If I undo that paste, and we can start again. And then we can think of another way of writing this code. So what I'll do then, I'll still create a function called each section. And then I want to think about what code can I run in there. Well, of course, the first thing I always need to do, because we're not on a square with anything on it, we need to move forwards. Now, rather than saying collect gem, turn left, move forwards, I could actually use a while loop here to create a little condition. So let's try that. Let's try using a while loop. So we can say while is on a gem, which of course we are once we've moved forward that once. Then what I want to do, I'll just make a mistake there, don't need those curly brackets. So while we're on a gem, what I want to do then is I want to collect the gem. I want to turn left, and then I want to move forward. And I'll end that bit of code there. Then of course that's going to do each section like I had before, but as you see I've probably half the amount of code there. So again it's just the same again as last time really, then a nice simple loop. So want to run this 4 times. And what I want to do is I want to run that function called each section. And one little bit actually I want to do, because I haven't turned right to face the right way each time the code's run, just need to put that command in here now. So I'll just turn right. So that's another way of doing it then. Let's have a look at what I've just written there. So what we're saying is I've created a function called each section. So in each section of this quadrant I want to move forward, and then I've used a while condition here. So while I'm on a gem, what I want to do is I want to collect that gem, I want to turn left and move forward, and of course when that's happened I'm still on the gem, so I want to collect that gem, I want to turn left and move forward. Now I'm not on a gem, so I want to run that section again, move forward, and then turn right. And of course that loop will then run 4 times. So I hope I'm correct in this here. I'll just press run my code and see how it works. If we turn right here, that's it, then that should be fine now. Then it should run through that code 4 times. So again, we just broke that challenge down into 4 different sections then, and then thought of a good way of doing it. Now of course you might have thought of another way that's even simpler, but that's the one that I sort of chose to do. You saw my first attempt, which was a bit more long-winded and a bit more too many instructions, and I combined those instructions using other skills, which was basically that while loop. So it says right on. Developing your own solutions for new problems enables you to figure out what types of tools work in certain situations. So again, just to recap there, we used a function, and then in that function we used a while loop. So it ran through each quadrant there, collecting the gems, and then we used a loop to run all of that each time we needed to run, which was the 4 times. So it did say we could also use if statements, which is conditional code, and some of the operators. So again, I could have put while is on gem, I could have changed that to while exclamation mark is not on gem, I suppose, if that's a condition as part of the Swift, and of course that would have just inverted that boolean value. So hopefully that's not really a lot of code to go through a whole square and collect 8 gems. So I hope you had success at it, and again, if you've done it once, maybe a bit long-winded, why not go back and think about it again and just see if you can find another solution. And why not try and find a better solution to me? There may be even shorter way as well, and that'll give some great satisfaction. So hope that's okay, and carry on with the next few playgrounds. So congratulations everyone, we've now reached the last section of this Learn to Code 1 playground, and no doubt a term that you've heard a lot in the last few years, and that is an algorithm. So again, you've probably heard it on the media and things, and different code and things. What actually is an algorithm? Now what I will say, in this section of the course it probably looks a lot more complicated than it actually is, but if we run through these slides we'll get a really good idea. So an algorithm is a set of rules and instructions you use to solve a problem. So again, whatever we're doing in code, we're trying to do something with our apps, then we're writing an algorithm each time. So for example, a navigation app uses an algorithm to figure out the fastest path to where you want to go. And what do we mean by that? Well, of course, there are different routes we can take. There can be some traffic conditions. One could be the shortest route. And in actual fact, if you use the Maps app on your phone or iPad, you've probably seen something similar to this anyway, where when you've asked for direction, it gives you 2 or 3 different options and the times there. So it's used to analyse different routes and times and things, and then created the best possible solution for you to get there in the shortest amount of time. Now this is interesting here. So suppose you need to direct a car around a building to find a parking space. So you can see there's a parking space there on the right hand side of that road. So what instructions and rules can you use to move the car around the building? So what we have here then is a while loop. So what we're saying, while, and we use the not operator there, the exclamation mark. So while we're not in a parking space, then drive forward. Well, of course that worked to a point, didn't it? But we just kept on driving forward and then ran off the road because we didn't tell it to turn at the end of the building. So now we can make it a bit more complicated. We can say, well, while we're not in a parking space, and if we're blocked on the right, which of course we are at the start because that building's in the way, then drive forward. But basically as soon as we get to the end of the building, we are then no longer blocked on the right, and so the if statement, or the else part of the if statement, tells us to turn right. So let's give that one a try. So it's not there, and of course now it's just continually turning right. So again, this algorithm thing really is about problem solving and thinking about how to achieve certain things. So it still needs a bit of tweaking here. So of course, what did we do wrong? We asked it to turn right, but of course we didn't ask it to drive forward again, did we? So now with this bit of code we have, we're saying if we're not in a parking space, so i.e. if we're driving, and if we're blocked on the right, drive forward. If we're not blocked on the right, turn right and drive forward. And so when it got to that second bend, it ran that code again, and I found that parking space. So this just says what I said a moment ago, really. A lot of the code you've written so far has been instructions to solve problems. So in actual fact, you've actually been writing algorithms this whole time. The skill you're now adding to this process of writing and tweaking code, so you can use it in different situations. So again, it just gets us to thinking about exactly what is the problem to solve, and then the different routes of solving it together. So if you press on the Start Coding button, we'll go into this first playground here on algorithms, the right-hand rule. So welcome to this first challenge in the algorithms section, and this is the right-hand rule. So we have the goal on the left-hand side there. Use the right-hand rule algorithm to navigate around the walls. In fact, if we look at the 3D world on the right-hand side there, we'll see a byte starts in the corner, and there's a gem and the walls that protrude out from that first row. And each time you run the code, it's one of those ones where the wall changes its length, so it could be any random amount of blocks. So if you look on the right-hand side, it says run this puzzle, and notice how your counter stops after the first gem. The algorithm used here follows the right-hand rule to move around the walls. And then we'll just leave that there. So if you look on the code, we've already been provided some code. So what we'll do is we'll run the code and we'll see what happens. It's built in there, look. So byte is moving around the wall. And let's see what happens. It's all looking good so far, isn't it? But now we've stopped. And again, this is really what we learnt in the introduction about algorithms. It's about looking at code and improving and solving the situation, tweaking it, adding it to find that right route. If you look at the code we've already got here, so we had this function called navigate around the wall, and in there we had this if statement. It says if we're blocked on the right, then move forward. And of course, once we are not blocked on the right, which is the else part, turn right and move forward. So actually looking at that function, the actual function navigate around the wall, that actually seemed absolutely fine. That seems to achieve what we're trying to do. So however long that wall is, if we're blocked on the right, then we'll keep moving forward. And as soon as we're not blocked on the right, so whether that's 1, 2, 10 squares, we'll turn right, move forward, and of course, and that'll run again right and move down the next aisle. So that function is absolutely fine. So if you look at the while loop, we're saying, well, while we're not on a gem, it's inverted, then run that function navigate around the wall. So that's exactly what happened. So we started not on a gem, so we ran the code navigate around the wall. We got to the end of the wall, made a return journey, but of course we didn't say to collect the gem, we didn't say to turn around and go around the next wall or anything else like that. So our code's sort of half written there, and we have to solve this challenge. Now if you go back to the top, this is introducing a different concept here, which might just help us as we get more challenging situations, and it's called pseudocode. So to solve the puzzle you need to tweak the algorithm, but first try using pseudocode to plan the action. Now pseudocode looks a bit like Swift, but it's worded and structured so humans can easily read it or understand it. So it's not Swift, it won't work, but it's written a bit more in conversational English, if you know what I mean there. So that example there, navigate around the wall, we haven't got FUNC for function, navigate around the wall, capital A, capital W. We've really just written it out in English, what we're trying to achieve there. And again, we're saying, well, if we block to the right, we want to move forward. Else we want to turn right and move forward. And then that second part is the while part. And we're saying there, well, while we're not on a closed switch, I want to navigate around the wall. Again, we haven't called it, you know, we haven't called a function. We're just writing navigate around the wall. If we're on a gem, collect a gem, turn around, and toggle the switch. So it's more of a thinking part, really. If you get a pen and paper and think, well, how do I achieve this challenge? Well, I want to write some code to navigate around the wall, and I want to make sure that code runs at the right time and using this loop. So write it out really in plain English. Now once you have that structure, you can then think, well, how does that actually translate into proper Swift code? So if you look at the bottom there, well, actually, if you look at the example, so the example is to navigate around the wall, and then that function written already is really all correct, isn't it? So we want to move around the wall, blocks on the right, move forward, else turn right, move forward. That part's right. The second part there, that while loop, is different to the code we already have here. Of course, that's where we went wrong, wasn't it? So what we're saying is we want to write a while loop now that says, well, while not on a closed switch, navigate around the wall. And then if we're on a gem, click the gem, turn around. And then when we get to the very end, there's that one switch to toggle. So we don't want to forget the old toggle switch there. So what we need to do then is we need to go into the code here. So we've established really that this while is on gem part is wrong. We actually want to think about it because there's 3 gems along the way. Switch at the very end. Now in our pseudocode we've said, well, we want to ignore the gem part to start off with. We're actually more concerned about this switch. So what we can say then is while we are not on a closed switch, then by all means we want to navigate around the wall. So again, that starts byte off the right way. So when we start the puzzle, we're not on a closed switch. In fact, we're not on any switch. So it'll run that function, navigate around the wall. But of course, we have got gems and things to think about as well. So we can now write an if statement in here. So we can say, well, the problem is when we ran that first code, we didn't really make any allowance for the gems. So we're saying now then, well, if we're actually on a gem, then of course we want to do something with that as well. So we actually want to collect the gem. That's what we're trying to achieve here. But then we're still facing the wrong way, as we can see bytes at the moment. So of course we need to turn around, so we can turn left twice, or we can turn right twice. That puts us in the right way. And of course, look at our pseudocode, we have that toggle switch at the end. So once all that code's been run, the very last part of this puzzle, if we spin it around, we can see there is that switch. So of course, at the very end of the code, we want to toggle the switch. So if you look at our code we've written now, then we're saying, and it's that while part that runs first really. So while we're not on a closed switch, then run the code, or run that function, navigate around the wall. And we've already established that function is absolutely fine. So that will navigate us around the wall. However long it is, it'll keep moving forward while it's blocked. It'll turn around and make the return journey. So back to that while loop then. Of course now we're saying, well, if we're on a gem though, which is where byte is now, we want to collect that gem, and we want to turn around, and then go round again, don't we? So that while loop will continue then. Sort of say, well, the while loop will continue for as long as that condition is true, while we're not on a closed switch. So then it goes through all the code again, and again, and again, until it gets to the very end. And of course that while condition at the very end will then be false. Because it'll say, well, if we're on a closed switch, then do this. But of course we are on a closed switch. So at the very end, we just simply want to toggle the switch. So hopefully, if we run this code, everything should work just fine. And hopefully I've explained that well as well. So now it's just one square there. So it says as soon as we're not blocked on the right, we'll turn right and move forward. And of course this while loop is now running. So again, it's running this part, navigate around the wall function. Now when it gets to the end of this wall, for the first time, or for the second time actually, we're on a gem here, aren't we? So now it's running that if statement. How are we on a gem? Well, yes, collect the gem, turn left, and then run that while loop again, which then is navigate around the wall. Again, we'll collect that. And I'll just spin it around, of course, because the last journey we've navigated around all the walls, there's no gems, and so it's a simple line of code at the very end that will then run, which is toggle the switch. So this is incredible, and really, if you've done that on your own, then that really is incredible, because you've looked at the problem, we had a bit of code, we had to tweak it, improve it, and eventually we've solved it. So really, we've created an algorithm for going around these walls. So it doesn't matter how long these walls are, we'll get around them, we'll always collect the gems, and at the end we'll make sure that switch is toggled on. So quite a lot there really, but as I say in the introduction lecture, it may look a bit harder than it actually is. So it's writing pseudocode, which is basically more English to understand, and then transferring that into Swift, thinking about the problems and solving them, and that really is an algorithm. So hopefully you got there. If you do have any problems actually, of course, we do have this button next to run the code, and of course we can step through the code. And as you can see on the left hand side of the screen there, that arrow shows exactly what we're doing at each point here. So you can see where the while loop's running, you can see where the function's running, and of course as we get to the very end you'll see where that switch is toggled. So as we move through this section, you'll notice we're really transferring code and bits across each time, so you need to do it in the right order here, and you can bring it across and again keep tweaking it, and at the very end of this course you'll be the master of algorithms, and you've completed this Learn to Code 1 playground, which is absolutely fantastic. And of course, once you've reached that stage, please look back on everything you've learnt, and if you did start as an absolute beginner, you should be really impressed with yourself, because you've gone from knowing nothing to knowing functions and loops and conditional code and operators, algorithms, loops, and you can confidently write all of those things. So you've come a really long way in a short period of time. I'm proud of you, and well done. So there you have it. You've reached the end of the course. Well done. I hope you've enjoyed it. Perhaps a few weeks ago you didn't really know what Swift was, perhaps never heard of it or knew what it looked like or the layout of it, and here you are now, you're writing functions and loops and if statements as you move by it around this 3D world. So really, well done. You've learnt a lot actually. When you look back, you'll have learnt a lot of things. You'll have also appreciated, of course, how important problem solving and looking for patterns and mathematics is when you're learning how to code and become a coder. So where do you go on from here then? Well, of course, we've just been through that Learn to Code playground, but there are other playgrounds you can download within the app which can further your knowledge even more. Perhaps you want to now go ahead and build a simple app in Xcode and trying to do that. But whatever you do, I really encourage you to try and do something. Otherwise, you'll just sit back now and forget what you've already learned. So try and put those skills into practice or learn some more to keep those skills developing. And of course, you can also keep active in the Facebook group. So you may have completed the course, why not go back, keep active in there, help other students, perhaps share ideas with other like-minded people and help each other out all together. But there you really have it. So you've learnt a lot. I hope you've enjoyed it, and thank you for taking this course. Welcome to this bonus lecture. Hopefully you've enjoyed this course. Just to let you know, I do teach other courses as well, and as a current student, I want you to benefit from the best possible price. So in the resource for this lecture, I'll include a link to my website where you can see all of my courses I teach, and you can get them for the best possible price, just as a thank you for being a current student. So hopefully that's okay. Do click on that link, have a look, see what's available, and hopefully I'll see you in another course. And once again, thanks for watching. Thank you.